Hello students, welcome to our channel Success Achievers. Today we are going to solve one question from JEE Mains 6th April second shift. Let's see the question. Given that a dipole comprises of two charged particles of identical magnitude q and opposite in nature. The mass m of the positive charged particle is half of the mass of the negative charged particle. The two charges are separated by a distance L. If the dipole is placed in a uniform electric field E such a way that dipole axis makes a very small angle with the electric field E, the angular frequency of the oscillations of the dipole when released is given by. This question is a contradictory question. In this question, NTA has given third option, but actually third option will not be correct. Okay, so there is no option correct. So we'll solve this question. Given that two charges equal and opposite, that means they are making a dipole in uniform electric field making small angle. So let's see. So we know the formula for this case, that if a dipole is making small angle with the electric field, it will oscillate in simple harmonic motion, and formula for that is omega is equal to square root p into E by I. Now we have to calculate the I here. Suppose this is minus q charge, this is plus q charge. They have given that plus q charge has mass small m and the minus q charge has mass 2 times of m. Then it will be 2m. Now in this situation, when we release the dipole, if the dipole is completely free, if there is no fixed point, then definitely the dipole will start to rotate about its center of mass. Here the mistake happened by NTA. NTA considered that the dipole will rotate about the center only, midpoint, but actually the dipole will rotate about the center of mass. So first of all we'll calculate center of mass. Let's see, for any two masses where one is 2m, another is m, we can calculate the distance of center of mass from any mass. Suppose this is the center of mass, L is the total length, then we can say this is R1. Suppose then R1 is equal to, we can say R1 equal to m2 by m1 plus m2 into L, where m2 is small m divided by m1 is 2m plus m2 is m into L. That will give you L by 3. So R1 is L by 3. R2 you can calculate. So R2 is equal to L minus L by 3. That is 2L by 3. Then moment of inertia about the center of mass you can calculate as IC is equal to m1 R1 square plus m2 R2 square. So m1 is 2m and R1 is L by 3 whole square plus m2 is small m and distance is 2L by 3 whole square. Then how much you are getting is, then you will get 2m into L square by 9 plus m into 4L square by 9. If you add them, you will get 6mL square by 9. That is nothing but 2mL square by 3. So moment of inertia about center of mass is 2mL square by 3. Now we can calculate the angular frequency. Omega is equal to, again we can say dipole moment is equal to length into electric charge. So Q into M. Here you will get square root P E by I, that means IC is equal to square root P is Q into L into electric field divided by, this is 2 by 3 ml square. Now L gets cancelled out and you will get square root 3 q into E by 2 times m into L. So this is actually correct answer. But NTA has considered as from the center only. Then we will simply get moment of inertia is equal to I is equal to, simply you can get 2 times m L by 2 whole square plus m into L by 2 whole square. That will give you 2 times m into L by L square by 4 plus m L square by 4. Ultimately we will get 3 m L square by 4. That means you can say according to NTA, omega is equal to square root q L into E divided by moment of inertia 3 m L square by 4. Now L gets cancelled out. It is equal to 4 times q E by 3 m L. So this is according to NTA, but this is wrong answer. Correct answer will be this one only, because the dipole is completely free to rotate. It is not mentioned in this question that dipole is bound to rotate about the center only, about the midpoint only. So if it is free, we'll consider the dipole will rotate about the center of mass. That's why the correct option will be this one. So there is no option correct. That will be your answer. Thank you for watching. Please like, share and subscribe for more videos.